So we're warming up on a worksheet 17B, number, I don't know, 7. And only doing part of this question because this was a question a lot of people missed on the test last week. So when I ask you to find the end behavior equation, usually that means the horizontal asymptote, but with number 7 being top heavy, you don't have a horizontal asymptote, but you do have an oblique asymptote. So you're supposed to perform division. This one is a good candidate for long division. And it's actually not too bad. The only thing that really broke my heart is some of you guys knew to do this, and then you still got the question wrong. We'll talk about why in a minute. Alright, so divide. Lead term by lead term would leave you with x to the first. So that goes up in your quotient position. And now you multiply the x to the entire divisor. Make sure you distribute it to everybody. And you get x to the third plus 6x squared plus 8x. And then this is a step where I still want to encourage many of your friends, they aren't doing this, and I think they should, using parentheses when you subtract these terms together. So lead terms cancel. 3 minus 6 is negative 3x squared. And then 2 minus 8 is negative 6x. So you still have enough to go through division one more time. So taking negative 3x squared now divided by x squared, that gives you a negative 3. And what I like about this question is we can actually stop. The quotient, when you ignore any piece of the remainder, is the body of the equation for your oblique asymptote. Unfortunately, some of you wrote down on your test, my oblique asymptote is at x minus 3. No. That's not an equation. So you have to write down y equals x minus 3. Make sure when I ask you for an oblique asymptote or a slant asymptote, it'll have the word equation. I believe it was in all capitals on your test on Friday. Maybe on the next test, I'll bold it and underline it too, and you'll remember that it is an equation, okay? You can't just write, I'll put it down for you. No, that's too much. Too much. Huh? Yep.
Oh, yeah,
I know. Some of you guys were very cute and creative with what you thought end behavior meant. Is oblique asymptote.
Hey, I was right. It was the right end behavior.
Oh, you didn't put y equals?
No, I'm just saying that was end behavior, what I wrote down.
No, it's not.
Right. What? Of course it is.
No, you need to write the line. Oh, child. All right. I'm going to skip that. Let's get to our lesson now, guys. Can you find worksheet 14? We're going to do 14A today, and then 14B is going to be tomorrow's lesson. I'm sorry.
It's just so nice when you can just go straight through.
It's just didn't work out that way today. So 14A, we're going to do polynomial inequalities. My friends who came from Honors Algebra 2 probably saw quadratic inequalities back in the day. I don't think regular Algebra 2 saw quadratic inequalities yet, but the good news is it's nothing new. We're going to be looking at graphs that we're pretty familiar with. We have our graphing calculators available to us on this test as well. And then we're going to be looking at where our polynomials are greater than 0 or less than 0. And that's just a fancy way of saying when is it positive and when is it negative. So if you think about like the way our graphs look, a function being greater than 0 means when your function is above the x-axis. So I'm going to do a lot of like pen coloring today. And less than 0 would be where your function is below the x-axis. But a big issue that we're going to run into today is my friends who still struggle with domain intervals. When I tell you that your answer is going to be a domain interval, does that mean you are using the x's or the y's in your interval? That means we're using the x's. Thank you. So you're going to be only using x values along with infinities when you give me your final answer today. All right. So with keeping that in mind, that some of our friends still struggle with domain interval, I'm going to use what I call a hybrid approach on the questions today. I'm going to do a little bit of algebra, a little bit of sketching and coloring, and then I'm going to go back to what's called a sign chart, which you guys really just are going to view as a number line. And it's going to take you back to the original part of algebra where you guys first learned about interval notation. So when you guys first learned about interval notation and your teacher had you graph something like x greater than 3, they'd have you mark down 3 on the number line, and then they'd make you like color everything greater than 3. And then you had to decide whether to use a parenthesis or a bracket, but like this one has a parenthesis. And number lines work really well for domain intervals because you just read them like a book. This domain interval starts at 3 and then goes off to infinity, right? That was a beautiful way for them to intro you guys to interval notation. So let's go back to our basics and let's do interval notation that way today. All right, so big rule for today, write yourself a huge note. You need to start in standard form. That goes for today and tomorrow. So when I look at this is a quadratic inequality, it was not yet in standard form. They did that very easily by just subtracting the 3 over. Standard form meaning all of your polynomial terms on one side, and then today they're going to be on the left side. And then instead of equals 0, you're going to have an inequality 0. Now, then they factored, which you guys can factor really beautifully, and they found what are called your zeros, your x-intercepts. So after solving your factors, they found out that there was an x-intercept at -3 and at 6. So, okay, that makes sense when I look at my calculator. And then I know some of you are thinking, well, can't I just find those on my calculator to begin with? And the answer is yes, you can. Most of the time. We'll talk about when you can't. So now when I look at my picture, and if I didn't have a picture on my paper yet, what I would do is I would just sketch it. This is the positive piece of my function where it's above the x-axis. Whoops. And then this is the, whoops, that's red. This is the negative piece of my function. Woo, who cares how low it goes because it doesn't matter. So notice my color coding there, green, positive, red, negative, makes sense to me. What they have right down here, this is what they're referring to as a sign chart. And then you're going to see your textbook. They do a lot of what's called testing. They're assuming that when you do this question, that you A, have no knowledge of what the graph looks like whatsoever, which I think is kind of lame, because I think you all know what quadratics look like. And B, they're assuming that you don't have access to a graphing utility if it is an unusual quadratic or an unusual polynomial. But guys, are you all comfortable with me saying if I have a quadratic that has an x-intercept at -3 and at 6, and it has a positive lead coefficient, are you okay with me saying it looks like this? Like, I have no clue how low it goes, and I don't care. Because what I'm interested in is the domain interval, or where it's positive and where it's negative. Okay? So I don't know if we have to do the testing part of the sign chart. I think we could just look at our graph. So what they wrote here is, on this, I'm going to call this a number line instead of a sign chart. They put your x-intercepts in number line order, and then they had you just simply ask some questions to yourself. Okay, when I'm to the left of -3, are we positive or negative? To the left, -3 is over here. We're positive, so they put a big plus sign down. And then between -3 and 6, are you positive or negative? You're negative. And then after 6, it's positive again. So when I go back to the original question, the standard form version of it, it says, where is your polynomial greater than 0? Well, that would be all these green parts here. That would be here to here and here to here. Notice that I didn't use a bracket.
Yeah.
Why did I not use a bracket? Because when in Algebra 1/Algebra 2 beginning would I put a bracket here?
When there's a point there.
If it says equals 0 in addition to, right? So it doesn't say equal to 0, so it's non-inclusive for the endpoint. There we go. So you're able to pick up the domain interval right off of what they're calling a sign chart. I think we could just call it a number line. I think that works great. And then there's another example that's kind of already done for you guys right underneath this one. If you tried to factor this, you'd be out of luck pretty quick. So then you try another method of solving, or maybe you just gave up and said, oh, forget it, I'm going to take my calculator and I'm going to graph it. And this is what it looks like. So I want to know where your quadratic is less than 0. So that normally would be when I take my red pen and I color every time it falls below the x-axis. Is this falling below the x-axis?
No.
No, it's not. So you're just going to say, like, never. You could say no solution. Whatever works for you, okay? There are imaginary values, yes, that is true. But we don't need to worry about them here. So, we're only going to be graphing real zeros. Now notice I said real, I didn't say irrational, so we could have irrational zeros. That's a little foreshadowing for you. Can we all look at number 1 today? Normally, number 1, we start off with a nice easy one, right? So like I'd dive right into factoring because look, it's already in standard form. And then I'd go to factor this and I'd be like, wah wah. Can you come up with two numbers that multiply to -2 and add up to -3? Me neither. So that means I have to use another method for solving. And maybe I was paranoid. Maybe I'm like, oh, maybe it's another one of those that never touches the x-axis things. Maybe they're imaginary. This one's not. These are just funky, ugly answers. So would you like me to complete the square or use quadratic formula? I think that's a wise choice. Okay, so quadratic formula, remember, is -b plus and minus square root of b squared minus 4ac. All of that over 2a. So, opposite of b for us would be 3 plus and minus. If I squared the -3, I'd get a 9. Minus 4 times -2. Over 2 times 1. So, these are not pretty. They're irrational. And you do have to kind of think about them as separate answers. I know if we were just solving, we'd just be like, boom, there's your answers. Deal with it. Well, that's not going to work today because we got to do intervals. So, our smaller answer is 3 minus the square root of 17 over 2, some gross decimal. And then the larger answer is 3 plus the square root of 17, all of it over 2. So here's what my quadratic looks like. Positive coefficient, one positive answer, one negative answer. So can we just, it looks like this. I mean, I know it doesn't look exactly like that, but just pretend with me. So who's this number over here? The gross one, yeah. The gross one. One of the gross ones, the negative one. 3 minus square root of 17 over 2. Who's this answer over here? Yeah, and both of them are icky. If I wanted a more pleasant looking answer, maybe I would type it in my calculator and get a decimal, but I really don't care. I want to know where this quadratic is less than 0. That would be all this part that hangs below the x-axis. So starts at, and then it ends at, you got it. Now notice I kind of cheated there. I did not do a sign chart this time. I skipped that little line graph thing. Those of you who are very strong with coming up with domain intervals, you're allowed to do that. Okay? Those of you who are like, I'm not sure if she's talking about me, maybe don't skip it for now. Okay, so on your homework, do the graph and do the line. Also notice when Taylor rattled off that interval, we were not using brackets. Why were we not using brackets on the endpoints? Because it doesn't have an equal to bar. So where it actually comes out to 0, the solutions are not included in our interval. Very good. All right, let's try this one. So this one does factor, and something kind of strange happens when you factor it. You get x plus 1 times x plus 1 again. And we know a shorter way of writing that would be x plus 1 quantity squared. So forget the inequality for a minute. Talk to me about what this looks like. You've got a quadratic that has a solution at -1. However, your solution of -1 has, what does this mean when it's squared like this? Has multiplicity of 2. So what would I expect to see on my graph? It bounces. Very good. Positive coefficient, so it's going to bounce this away. And I don't really care how skinny or wide it is. I just need to know the general shape. So this time I want to know where this quadratic is greater than 0. I was hoping you'd say that. Is it greater than 0 everywhere? What about right here? Uh-oh. Almost everywhere is a better answer. Okay. It is almost everywhere positive. The problem is once you hit -1, you're no longer positive. You're exactly equal to 0. So you cannot include -1 in your interval. So if you wanted to switch this over to a domain line, a line graph, it's positive here and it's positive here. However, you can't include -1. So what does that look like when I write it as a domain interval? It goes from -infinity to -1. How do I not include it? Parenthesis. And then how do I go to the other side of it? Union. Very good. And then again, I don't include -1, but I continue on forever. That was a bit of a trick question. Sorry. All right, let's see a more typical one. Number 3. Now, first of all, is number 3 in standard form? No. Okay, so do a little work. And this goes for today and tomorrow. Always has to be in standard form. So x to the third plus 6x squared plus 5x, and then you want to subtract the 12 over. Now I want to know where this polynomial is greater than 0. And then I would either have to factor it, which this one does not factor through any methods that I'm familiar with, or I could like do some creative synthetic division to factor it, or I could just be a big old cheater on a Monday morning and say, can we just graph it? And yeah, we can. You can just graph it. So, well, it's using your resources, you know? So here and here and here, you should be able to confirm pretty quickly where it's going through the x-axis. And apparently it's going through the x-axis at -4, at -3, and at 1. So I would like you guys to take the time to write them in factors. There's no bouncing this time. So what, x plus 4 times x plus 3 times x minus 1? Let's take a hybrid approach. Let's do the number line, but let's also color the graph. Now you guys don't have a picture of the graph on your paper. So what I'm going to need you to do is what you're going to have to do on your homework too. Give yourself, could be the world's ugliest sketch, it doesn't really matter. It doesn't really look like that, but it really doesn't matter, guys, I'm not kidding. And then bust out your red and green markers, or highlighters or whatever. And all the positive parts, maybe you want to color green like me, or whatever color you're using. And all the negative parts, you want to color red. It would be smart of you to also involve some x values where they're changing colors. I think that might be important to your little graph, okay? So, answer me this. To the left of -4, are we positive or negative? To the left of it. Negative, all right. In between -4 and -3. Okay. In between -3 and 1. And then to the right of 1. Okay. Now I know the next question. A Bruzo, are they always going to alternate? Positive, negative, and that was a quick no from some of you. See the last question we just did. It wouldn't alternate if it bounces off. So we got to be careful about that, okay? All right, so go back to the actual question. What do they want from me? They want to know where your polynomial is, what does it say? Greater than 0. So I want to know this interval and this interval. Notice I put parentheses on my number line because there's no equal to bar. So it is positive from -4 to -3, but also, thank you, 1 to infinity. Not too bad, right? Now the next question, it bothered me that this set of notes didn't have a single question that had an equal to bar on it. So can you please change the question so that it says less than or equal to? Just so we get a little variety in our lives. Okay, so while we've changed that, can you guys tell me whether we're in standard form yet? This is not in standard form. So subtract the 2 to the other side, 3x squared plus x minus 2. I want to know when it's less than or equal to 0. All right, this one does factor really nicely. It would be, I know some kids don't believe me, but it is actually faster to use an algebraic approach here to find your intercepts rather than graphing it, but that's up to you. So this one factors, let's see, how about 3x minus 2 and x plus 1? Does that work? That's positive 3 minus 2 on the arches. So y'all find that you have an x-intercept at 2/3 and at -1. So I'm going to steal the picture from Mrs. Hoffbauer's screenshot, and I'm just going to label it. I'm assuming this is -1, and this one must be 2/3. So, busting out my colors again. Here's the red part. It's below the x-axis. This is above the x-axis. Those are the positive regions. Huh? I know. These get pretty colorful. Pretty artistic, eh? Alright, so Got our x-intercepts on our number line. Those of us who struggle with domain, this is going to be the key to your success, okay? Writing your x-intercepts on a line instead of the graph. To the left of -1, so before it, you had some positives, positive outcomes, right? It's up, up, up. I shouldn't say that word. You're going to get confused with behavior. What's happening is your y values are coming out to positive numbers. If you're above the x-axis, your function is giving you positive outputs. All right, between -1 and 2/3, you got some negative outcomes, and then after 2/3, you got positive outcomes again. Now, what did the question change to again? They wanted me to know where it was less than or equal to 0. So this time, I want to know the negative region. But because I threw some equal to bar on the problem, now we're going to use brackets. This is a case where you would use a bracket. So -1 is included in my solution because I threw the equal to bar on the original problem. I just changed that problem because I saw when I looked ahead in your homework that there were some that did have brackets, and I didn't want that to be the first time you ever considered a bracket, okay? So speaking of homework, you guys are going to look at worksheet 15, and you're going to do numbers 1 through 5 tonight. And then tomorrow, after tomorrow's lesson, you're going to finish it up and do 6 through 10. Do not touch 6 through 10 yet. You do not know how to do it yet. Could you please? You're going to do numbers 1 through 5. You'll be fine. Could you take a look at worksheet 13 next? 13 is part of your homework check, but it's really quite difficult. And it's not something that we're going to test you on, but it's just an extension of something we're going to test you on. So we're going to basically do worksheet 13 all together. That's the plan.
Starting with A or starting with
A. But before we actually start worksheet 13, I have a couple warm-up questions for you. Let's see how you do. All right, you might want to get your yellow card out, the one that tells you all of the steps for, how you find things for rational functions. So worksheet 13 is kind of backwards. I'm going to give you the picture, and you guys have to come up with the graph, or the equation, excuse me. All right, real quick though, this is a sad moment for your teacher. This is when I find out that no one did their homework at all this weekend.
What are you talking about?
I know, I apologize if I'm not including you in this. But, well, the homework I'm referring to is the homework that was assigned to you like last Monday, 2.4. Bookwork.
The one that
I know. And then I understand we had a lot going on last week. And then after the test, I was like, hey, make sure you catch up on your homework this weekend. And I don't know that all of you did. And I'm about to find out just who caught up on their homework right now. State all the possible rational roots for this. Uh-huh. We were working on this the other day. What if I wrote this down? Does this ring any bells for you?
Plus or minus.
Yes.
E.
So then you're supposed to look at the constants,
Yeah.
and you're going to give me all the factors for 56.
Okay, so got it.
So 1 and 56. Oops, why am I putting a comma
2
there?
and 28.
2 and 28.
3 doesn't.
No, but I think 4 does.
4 does.
4 and 14.
Yeah.
And then 7 and 8. So there's all your factors of 56.
Yeah.
But that's only half the story. Now you got to talk to me about all of your factors of your lead coefficient,
1 and 2.
which are just 1 and 2. But this isn't. This is not okay. We can't leave our answer like this because this is a bunch of gibberish.
Yeah, and 1 and 2.
So all of the whoa. Oh goodness, child. All right, all of the possible zeros. Now I'll just make you write plus or minus down one time. We'll just assume it carries through the list. If I took all of these green guys and divided it by 1 at a time, I just list out all the green guys again, right? 1, 2, 4, 7, 8, 14, 28, and 56. But then if I came back through and I took all those green guys and divided them by 2, I would get 1/2, but I'm not going to write down 2 over 2, because that's a 1, because we already wrote that. 4 over 2, already wrote that. 7 over 2. I got to write that one down. 8 over 2. Nope. 14 over 2. Nope. 28 over 2. Nope. 56 over 2. Nope. That, my friends, is a list of all possible rational roots. That is a question on your homework. Several questions on your homework from 2.4. You had a little book assignment on that. That is also a question you will see on one of the very first problems on a section of your test. It's probably the first question on the test, actually. I'm going to go out on a limb. It's probably numero uno.
Is it on 2.4?
Yeah. That's why I put a 2.4 next to that. So, we want to make sure that, I know it's been a while, but you still need to do that homework. This homework check is large and in charge. I don't want to hear that.
8 pages.
It's a lot of stuff, guys. All right. This is not on a worksheet anywhere, guys. Just walk through this one with me. Let's see what you can come up with. So, look at your yellow sheet for a little inspiration here. What if I told you we have a rational function that has an x-intercept at 0 and at 4? First of all, where in my rational function, numerator or denominator, do I go looking for my x-intercepts? Check your yellow card if you forgot. Your x-intercepts or your zeros? Is that up top or bottom? In the numerator, very good. So if you have an x-intercept at 0, his factor, you can just call it an x. What about x equals 4? What does his factor look like? Yeah. Okay, cool. Check 1. Okay, now, what about a vertical asymptote?
That's in the bottom.
Those are from the denominator. So what does the factor for x equals 1 look like? Yeah. Uh-huh. Great. Now there's one more clue. It says you have a horizontal asymptote at y equals 0. What does your yellow card say about horizontal asymptotes at y equals 0? That would only be if they're bottom heavy. Y'all, you have a quadratic over a quadratic. That is not bottom heavy. So I have to make it bottom heavy, but without introducing any more vertical asymptotes to it. Could we just do this? I know, so I pointed at you. Shout out to Adam.
How is that not introducing?
Okay, so here's what this does. And this is, we kind of briefly introduced this to you another day, because I think actually, Daniel, you asked a question about this. Normally, when you have a vertical asymptote at x equals 6, if it just shows up one time, you see this, where like one side goes down to negative infinity and the other side goes up to positive infinity. When it shows up one time, you get that. But when your vertical asymptote factor shows up with multiplicity, what happens then?
Oh, you get a little parabola.
No?
No. Because that's what I remember asking about the other day.
They go like this. So it's still the same vertical asymptote, but the branches are going to both go off to either positive infinity or negative infinity, depending on some other things in the function.
How does that not introduce another?
So it's got the same vertical asymptote. It's x minus 6 with another x minus 6, so it's the same place, but the behavior along the asymptote is different. So if it shows up with multiplicity of 2 like this, you're going to see the ends go up to positive infinity. Like, okay, so that kind of leads us into working on worksheet 13. Again, I'm not testing you on this, so if you're like, this is a little above my pay grade on a Monday, I gotcha. We're going to work through this together, guys. Can you look at worksheet 13? Do not worry about this limit business. I'm not worried about this stuff. Let's start by looking at, same order of that last question. Do you see any x-intercepts or zeros? And I know it's a little hard to read, but...
Looks like it bounces at like 3.
Okay, there's a bounce at 3, negative 3, yes. And then I think something similar happens here at x equals 4. Do you see a bounce in both places?
Yes.
So where in my fraction does the x-intercept factor show up? The top, in the numerator, good. So your factor of x plus 3, because you guys told me it bounces, it's got a square, very good. And then something similar for x minus 4, that factor, it bounces at 4, so you need to square it on that as well. Okay. Now, do you see any vertical asymptotes? At x equals 3. Now, Daniel, look at that.
What?
Do you notice how both branches are going up to positive infinity along that vertical asymptote?
Yeah.
So the vertical asymptote's factor is x minus 3, but because they're both going up to positive infinity, you have to indicate that it has multiplicity of 2. And the only reason I know that is because they're both going up. Okay? You look uncomfortable with that.
Yeah, I'm completely.
If I wrote them,
it doesn't make sense how you take you said that you can't introduce another.
Okay. Look at this. Tell me where my vertical asymptotes are at. X equals 3, and also x equals 3. Is that different? Are those different vertical asymptotes?
No, it's not different. But when you, I'm still confused from
on that warm-up question, the warm-up one.
Yeah, because you started out and you had it where, right? You started out with x minus 1 and x minus 6, and then you just tossed a little 2 on it
because it had to be bottom heavy, so I needed extra factors in the denominator. Now, remember how these questions like have a bunch.
Mathematically not allowed.
Okay, I think the issue that you're running into is you figured this is the only right answer. This is not the only right answer.
Can you show me a different one then?
I could have put the 2 on here. I could have put a 4.
But still, you're just tossing a little number in there without. Without what seems like any sort of rational.
I also didn't talk about the fact that there could be a coefficient in front of it. So there's many answers you could have come up with. It's a rule of whatever you come up with, it has to meet those 4 criteria that I gave you. It has those x-intercepts and those vertical asymptotes and that horizontal asymptote.
Oh.
Okay? So there's a lot of answers. Yeah, I'm not saying like the answer I just came up with is the only answer.
Right. No, I forgot about the fact that we were actually writing the equation based off what we were reading.
Right.
Like that's analyzing a graph rather than actually.
Yes. So here we're going to be a little more particular because this time I have more information to work with. Okay. Now, guys, I hate to break it to you, but we are not done. Because of what Daniel was just having a conniption over. He's like, but wait, you just threw a 2 and then you're going to walk away. I'm not going to walk away this time because they gave you another set of information out here. Do you see it? Based on some coefficients that I don't know about yet, they said, here's your y-intercept, use it. Okay. Well, this is technically an xy ordered pair. Here's what I'm going to tell you. If you're using pencil, could you please do something for me? Could you write a k in front of this? Guys, there's some stretch on this. There's some coefficient that I don't really know about yet, but I'm about to find it. Okay, use that xy ordered pair that they graced you with. Plug her in. So instead of y equals, I'm going to write down 24 equals. I have some stretch I don't know about yet. And I'm going to plug in a 0 for all my x's. Alright. Now, normally, I would ask everyone to muscle through this in their old noggin, and I realize some of you were like, nope, it's Monday. So you're probably typing all this hot mess into your calculator, but I think we got this, guys. This is 9 times 16 divided by 9. That's just 16. So you got 24 equals k times 16. So when you divide both sides by 16, and then you like bust out your 5th grade math skills and you reduce that fraction for me, you just found out that k is 3 over 2. So then I go back up to here and I go, you're not k, you're 3 over 2. Oops, why won't you let me stay up there? Okay, so that's like the hardest one on the worksheet. I don't know why it's number 1, but it is. Wasn't that good time? Okay, let's do one more. Apparently not that one. That was already done for you. Can we look at this? Thanks, Hoffbauer. Spoiler alert much. Alright, so did you notice that she identified we had an x-intercept at -3 and at 2, and she wrote them up here as factors? We'll talk about the 20 in a minute, though. And then it wasn't really clearly labeled, so that was nice of her to do this for us. There's a vertical asymptote at -1 and at 4, but do y'all notice that on these vertical asymptotes, the branches are going in opposite directions? One up, one down, one up, one down. So that's why you see the vertical asymptotes just showing up one time. So where the heck did this 20 come from? It says you have a horizontal asymptote at y equals 20. Well, in order for that to occur, you would have to have an equal weight rational. Is this equal weight? And your lead coefficients would have to reduce to 20, which could be a whole lot of things. But can we all agree that 20 is 20?
Yeah.
So she just stuck a 20 in front. I love it. You could have done 40 over 2. Guess what that reduces to? 20. Okay. So we're going to continue on with that tomorrow. Remember tonight for homework, apparently you're catching up on your homework, but you're also doing worksheet 15, numbers 1 through 5.